Okay, then again, Kedah start from 2018 until 2021. You get the point now? So you arrange your state, okay? And then here, for example, this is your GDP. Can I use the word GDP? GDP for police. Okay, 2018. GDP for police, 2019. GDP for police. Okay, you get the point. You need. That's why this one, the thing you need a very good micro level data. Okay, without that you cannot do. You cannot. Then after next thing, maybe okay, we want CO2 emission. Maybe for that. How number of school, number of school in the state, for example. Okay, number of doctor in the state, for example. Okay, number of hospital in the state, for example. Okay, you get the point now. So you need for that particular year. Okay, I think you roughly know, right? Not sure you know. Okay, so basically for the panel data, first thing first, you need to arrange them in Excel worksheet. Okay, Excel worksheet is very important. So let's say I'm using Kedah Police, let's say I'm not. I'm using Maybank, for example. Maybank, okay, 2018, 2019, 2020, only 3 tahun. Then after that, Afin Bank, 2018, 19, 2020, okay? Then maybe Maybank 18, for example, what is the profit? What is the asset? Okay, what is the ROA? ROE, for example. Okay? So this one you can get the data, right? 18 berapa, 19 berapa, 2020. Then go to Afin Bank. Okay, then go to maybe Bank Simpanan National, right? You get the point? So you arrange, for example, Maybank. Just now, Maybank, Afin Bank, BSN, then whatever, Public Bank, whatever bank, CNB. 18, 19, 20, then 18, 19, 20, 18, 19, 20. Okay, and then for the year, what is the profit? What is the asset? What is the ROA? Depends what kind of model you want to do. Okay? So actually, panel data is very powerful. Panel data, basically, you need to use a software called Stata. Very, very powerful software. Maybe email is not really that good. If you can have a chance to get the software called Stata, very good. This is called Stata. Okay? Software. This is software. This one very good. And then for panel data, it's very powerful. For example, in World Bank, World Bank, IMF, they do a lot. Because World Bank, for example, they need to study many countries. Let's say in your study you have 50 countries, OIC, 50 countries, or let's say G20 country, 20 negara, right? G7 country, for example. Okay? So they do that kind of study, panel data. Okay, for example, you Google, let's say you just, you just try Google Scholar, for example. Let's have a look. Okay, Google Scholar. Okay, so let's say you just go in there. Okay, anything, you just type panel data. Okay, panel data analysis. Just Google. There are many, right? Analysis of panel data. Many, a lot. The title normally they have panel data, but this day even better. This day now they got non-linear panel data. Okay, non-linear model. So what is a non-linear? That means non-linear basically means, for example, x and y, right? When your x increases by 1 unit, your y increases by, let's say, 1 unit as well. But when you have non-linear, that means when x decreases by 1 unit, your y decreases by 3 units, for example. Okay, so that means increment is 1 to 1, but when you decline is 1 to 3. That's called non-linear. The relationship is non-linear. Okay, the proportion is different, non-linear. Okay, so coming back here. So that is your panel data. So panel data is basically a micro level, firm level data. It's a combination of time series and cross sectional. Okay, that's called panel data. And another name is called longitudinal. Maybe you know? Longitudinal. That means it's a wrong llama, let's say across 5 years, 6 years, right? Okay? Longitudinal. Okay, so control individual heterogeneity, individual character norms. Okay, more larger data set. So basically, when you use larger data sets, so multi-query is not a problem anymore. Okay, multi-query is not a problem because your data set is very large. You pull the individual and also the time together, right? More variability, yeah, so that less continuity. Can you see? So your data is very rich, okay, and therefore a very chance to have very small chance at multi. In fact, in the banner data, we don't care about multi-query anymore, okay, because the data set is very large, yeah? Okay. And basically, why we want to do banner data because there's such thing called unobserved heterogeneity. Many individuals are not observed, controlling for individual heterogeneity. What is a heterogeneity? For example, that means different country or different states. Sorry, I'm trying to draw that. Different country or different state, basically, they are different, right? Because the endowment is different, right? I'm trying to draw this. Okay, let's say this is Kedah, this is Perlis, this is Pulau Pinang, this is Perak. Every state is different because the starting point is different. You get the point? The starting point, and that is called unobserved heterogeneity. The differences that cannot be observed because of that. So, for example, you go to different countries, the same thing. You cannot compare Malaysia and Japan, for example, because the starting point is different. History is also different. Okay, so that's called unobserved heterogeneity. Okay, let's go on to look at the basic in terms of the modeling. So you use ID. What's ID? I stand for individual, number proper. T stand for the time. Because in the panel data, you got two dimensions, right? The individuals, for example, the individual of the state or the bank, for example, bank number 1, bank number 2, bank number 3. Individual number 1, individual number 2, or just now we say state number 1, state 1, police. Example, we follow the sequence. State 1, police, state 2 is Kedah, state 3 is Pulau Pinang, right? State 4 is Perak, right? Continue, right? According to the kedudukan, right? The geography. Okay? And then this one intercept, and then you got whatever just now I mentioned, your ROA, for example, or your GDP state, for example, right? And so forth. Okay, epsilon ID is a random, this one same, random variable, normally distributed with 0 and variance. 0 mean and variance sigma. Okay, how to estimate the next thing? How to estimate the model? So there are three models. Pool, or somebody say pool OS. Pool OS model. Pool means you put them together in the Excel worksheet. It's called pool, right? Random effect model, or the fixed effect model. Fixed effect model, as I mentioned to you, every state has a different. You try to buktikan bahawa setiap negeri ada intercept yang berlainan. They mean the unobserved heterogeneity is there. Setiap negeri is different because the starting point. Ataupun setiap negara, let's say you run a G7 country or a G20 country, you try to buktikan bahawa, you try to prove that the starting point of the country is different. In fact, they have a different endowment. Okay, they are different. Okay, that's called the fixed effect. Fixed effect model. Okay, the pool model, right? Let's start with one. Maybe we start with model, and then after we will continue another time. Okay, pool model ignore the planar nature and treat epsilon as an identical. Okay, what is this one? They mean they are all randomly distributed and uncorrelated. These are our usual assumption. In this case, the data can be pool or else can be used to estimate. The pool model essentially postulates that both intercept and slope are the same across the time. However, this is restricted. Okay, so that means when you say pool model, that means they're all the same. So basically, you just put them together. Okay, whereas you go to fixed effect model, you try to buktikan bahawa the starting point is different. Okay, the starting point is different. Okay, here for example, or maybe you should go to this. After this, we go to this. You stop halfway, maybe you not feel you're not happy because I stop halfway. We had better continue. Okay, so pool model is very restrictive in terms of modeling because you assume the intercept and the slope are the same across country, across time. Okay, so maybe it's not real, right? In fact, most of the time you realize that this model tak jadi one, this model. At the end, after all the testing, this model tak jadi. But this is the base model to start. Okay, this is the base model to start. Most of the paper you realize that the study either show is a fixed effect or is a show is a random effect. Most of the study will show. I think most of the paper I read, they hardly full model say, oh, this is the good model. No, you hardly see this is the answer. The answer will be fixed effect or random effect. Okay, full model is just but you still need a base model to start with. This is a base model, right? So pool relation will result in heterogeneity bias. The often reason why intercept or slope may be different. Heterogeneity means units from different are all different from one another, and vary across image. So that's why I say heterogeneity. Every state is different, every country is different. No country is the same, right? Okay. So basically, you find that pool model assume everyone is the same. So ini mana boleh jadi, right? Tak boleh jadi, because pool model assume everyone is the same, right? Okay, allow for different intercept. The second and the third approaches, random effect or fixed effect, assume each unit has their own intercept. This is more real, though. More real. While restricting the slope to be homogeneous. Okay. To accommodate for such heterogeneity, the epsilon ID is decomposed. Diuraikan bahasa, okay, into two independent components, lambda t and epsilon t, ut. Lambda t is called individual effect or unobserved heterogeneity, and it's time invariant. They mean tidak bertukar. The fixed effect, tidak bertukar. Even different, whether today is 2023 or whether it's 2015 or whether it's 2010, the effect is there. Okay, heterogeneity effect is there. Okay, individual effect. Unobserved heterogeneity means your starting. As I mentioned, the word endowment effect is there, right? Okay, so UT is a remainder error. Regular error term is assumed IID and zero mean variance. Okay, so testing for individual lambda, you can test first assuming lambda are independently from some, so independently, or fixed effect, assume lambda is constant for individual. Okay, so that's fixed effect. The lambda is constant. Okay, random effect, the lambda boleh bertukar independently. Okay, let's move to fixed effect first. So estimation, we assume the third estimation strategy is called upon when the individual effect are assumed to individually specific intercept, or more crucially when correlation between error term and xi is not equal to zero. This is called the fixed effect model. The lambda is a constant. So now your beta got one more term. Your beta got one more term, there is lambda. Can you see? Just go back to the original model. This is your model, you only got the beta 0. But here, you have one more term called, you have this lambda. What is lambda? Can someone tell us lambda? Lambda is a unobserved heterogeneity. I mentioned 3 times already. Lambda is what? Unobserved. What is unobserved heterogeneity? That is the endowment. Okay, yang membezakan setiap negara. Okay, yang membezakan setiap negeri. Right? Okay, the different state, the different individual. Okay, yang membezakan setiap individual. You and me are different because the unobserved heterogeneity. Our endowment, our starting point is different. Okay, or maybe our target, our habit is different. Our style is different. Right? Okay. Example, this is just a term only. I use it. Okay. Here you say already, heterogeneity means units are all different from one another. That's it. Okay, and the reason because certain reason is that's why we are different. Continue. We have econometric, econometric. Let's continue. Okay, so now two versions of fixed effect. Kita boleh menganggarkan dua cara. First is called within group fixed effect. The other one is called D square dummy variable fixed effect. Okay, so only we discuss LSDV fixed effect. Okay, one is within group, one is LSDV. Okay, LSDV fixed effect. Unobserved is brought explicitly. So kita nak modelkan curve represent itu. We want to show the difference. Okay, and how to do it? We put dummy. Setiap negara, katakan kita start with contoh, let's say we assuming G7 countries, so every country got a dummy variable. Okay, let's say we assume 13 states in Malaysia, every state also got a dummy variable. Okay, so we assume the dummy equal to 1 in the case observation to the individual I, 0 otherwise. The unobserved effect is now being treated as a coefficient of the individual square dummy, beta naught plus alpha, representing the fixed effect of the dependent variable y for individual. And the work model is fitted using OS. Okay, so this is the model. Extra thing is this part. Okay. Okay, let me go back to what is the random effect? The lambda is assumed to be random variable with 0 and zeros and uncorrelated with a regressor. So this is very important. Kita mesti buktikan ini. So when you do the testing, you need to test whether correlation between lambda, epsilon, IT are equal to 0 now. Equal to 0, go to random effect. Not equal to 0, go to fixed effect. Okay? The random effect is characterized by random. So here the random is here. Okay? When you see model, put lambda behind is what? Random effect model. You see the lambda in front is what effect? Fixed effect model. Okay? You see the difference? Here, this is a fixed effect, right? You see the lambda where? In front. Betul? This one where you see the lambda? Behind. Behind is a random effect. Random effect, okay? So epsilon lambda plus U error multiplied with lambda is part of error term. So the lambda I and error is a composite error term. We have variance. So they got different variant respectively. In the random effect model, the error term epsilon is serially correlated with the unit. This is because all observation within unit has a common component. Okay, so this is something with the random effect. Next one. Because of this autocorrelation, OS will be inefficient and most seriously, OS standard error will be invalid. Thus, we require the GLS. The GL estimator involves estimating the following transform model. Okay, yi minus theta y bar equal to constant plus beta xit minus theta beta x bar, where your theta is 1 minus this. If all individuals had same intercept and theta is 0, the RE estimated become OS. Okay, if this becomes 0, let's say this becomes 0 and theta becomes 0, then it's just an OS model. Okay, so very quick one, a quick summary. A quick summary is, if you see your lambda at the end of the equation is the random effect. If you see your lambda in front of the beta, then this is a fixed effect model. So for fixed effect model, this one is not equal to 0. For random effect model, this is equal to 0. Right? So if you do not reject, you go for random effect. You reject, you go for fixed effect model. Okay? Okay, so this is the beginning of the new topic called banner data. Okay, I'll stop here. Okay, a good start. Okay, so next week we continue, okay? Okay, good. 2 more topics to go. 2 and 2.5, 2.5 topics. Okay, after that we do revision. Attendance, all signed? Okay. Welcome to take photo. If you don't want to take photos or revision, please.